Good afternoon, ladies and gentlemen. We really appreciate you are joining us in KOIKE web seminar today. My name is Yodono from KOIKE Japan. We have studied KOIKE Private Fair 2021 from November 25th and already completed 4 private fair days until last Friday. Each private fair days, so many customers are visiting our Toke FA Center. Also, last Tuesday on November 30, we have organized the first KOIKE webinar 2021 as topics welding carriage. And around 50 audiences have joined in our web seminar. From now, we would like to start the second KOIKE web seminar. Today, our main topics is KOIKE FIBERTEX-DBC laser. All visitors to KOIKE private fair are very interested in our FIBERTEX-DBC laser cutting machine. Now, the Japanese major steel service centers are very excited in KOIKE DBC fiber laser technologies. The presenter is Mr. Wilson Fernandez from Overseas Sales Group. Let's start our webinar now. Wilson-san, お願いします。
Hello, everyone. We are here to talk about the FIBERTEX, which is our new machine. I think you are all remember we have the fiber graph before, and the FIBERTEX is an improvement from the fiber graph machine with some new devices, new technology, and new possibilities. As everyone knows, in the past few years, the fiber laser industry has improved a lot. We jumped from 10 kilowatts, 12 kilowatts, and now even higher capacity is possible recently. KOIKE launched a couple years ago the 12 kilowatts fiber laser with the fiber graph, and we kept improving it. Most recently, KOIKE introduced their new technology to the laser cutting technology, targeting the market where KOIKE is already the leader, which is the cutting of thick material with fiber laser. This new technology introduced by the KOIKE with the FIBERTEX is the DBC. We call them DBC, which is dual beam control. This new technology consists to a new high quality CW cutting, which comes to improve the cutting of thick material. But not only that, we also can cut effectively some kind of rust material, which is a very good improvement. However, as everyone knows, each plate thickness needs different parameter, and KOIKE can propose the most suitable cutting method according to the material to be cut. It is in order to achieve the best results. For example, for thin plates, like we are seeing here, 3.2 millimeters, the pulse cutting is still recommended. For 9 to 16, which is still a thin plate, we can use the CW cutting. And the new technology we are introducing now is more effective, is more applied for 22 millimeters thickness above. So what is this technology? Is a CW cutting, high quality, with pre-burning system. and this can be applied for the SS400 plate material, and also stainless steel SM490A. So thick plate over 22 millimeters are usually difficult to cut, even by CW cutting for the 12 kilowatt single bin. The new 12 kilowatts DBC changed this, making it possible to cut plate over 22 millimeter effectively. For a steel plate with thick black skin like SS400 25 millimeters and the SM490A 28 millimeters, cutting achieves stable cutting and product accuracy. Even for unmanned operation, using this new high quality CW cutting with the pre-burning, the qualitativity is superb. Over the years, pulse cutting has been applied for the cutting of thick plates. The YOCW cutting has been applied to cutting of thin plate and the small items. However, due to the high output of fiber laser and advances in the cutting technology, there was some changes in this usability. But most importantly, what's difference from these two type of cutting? What differs pulse oscillation from CW oscillation is the pulse frequency and the duty. While in the pulse oscillation, the duty change between on and off, the CW oscillation is continuous. As you can see here, there's the wave for the pulse frequency is changing on and off, and each one is a pulse. And in the C oscillation, there is no change. The duty is 100% continuous. So even we are presenting some special function today, there's some material, as I said before, then we can use the usual cutting functions. So the pulse cutting we can see some samples here that for the pulse cutting for 3.2 millimeters plate, the cutting quality are almost the same from CW cutting and pulse cutting. So when we cutting small shape, like small circle, the cutting speed must be reduced to achieve cutting accuracy. So this reduces the bin output along with the deceleration. That is the reason the pulse cutting is more effective for the thin plates. For medium thick plates with like 9 millimeters and 6 millimeters, the application of CW cutting enables the optimum cutting operation that match high productivity by high speed cutting with cut surface quality and acute angle accuracy. So the difference between the top of the cutting and the bottom of the cutting will be very small when you use the CW cutting, and the surface quality also is better. Same for 6 mm here. When you start to cut the thick plates, cutting by pulse cutting, the curve width is very narrow. In this case, the flow of molding metal needs to be optimized by using a large nozzle diameter to increase the assist gas supply. But this will also increase the difference of the vertical angle. So the difference between the start point, cutting point, top point and the bottom top will be larger, will be very bigger when use a large nozzle diameter. And also the scratch, the appearance of the scratch will be bigger. In case of material with large amounts of chromium and silicon also, the molding balances in the curve, the narrow curve, will be lost, and surface roughness, gouge, and dross adhesion will be even more in this kind of material. Also, the sharpness in the corners will be affected because of the curve width. But in CW cutting, the high output improves the cutting speed, which reduces the curve width. It improves the flow of the molding metal and leads to a better cutting surface. So between these cutting by pulse cutting and the CW cutting, we can see an improvement in the roughness and also in the corners. Although it has some advantages, improving productivity and sharpness quality, the current CW cutting technology may require some post-treatment in the cutting material, like oxide scale removal from the bottom side of the cutting material. There is where the new technology of high quality CW cutting enters. Here, the cutting speed slows down, but improves the cutting surface roughness, vertical dimension difference, and gouge also is reduced. So comparing to the previous CW cutting technology, the new one has a better result in the roughness. The corner is also sharper and a little bit better from the other the previous function, previous features. But when we apply the newest technology with the new high quality CW cutting together with the pre-burning, the cutting quality is even improved. In case of steel plates with thick black skin, performing pre-burning with the high quality CW cutting provides a better cutting surface with almost no notches, no scratches here. Cutting speed also will be slower, but applying these cutting methods to unmanned operation, it improves the results significantly by eliminating most of the negative factors of the unmanned operation. It means even the stop for fail cutting will be reduced significantly. And when we talk about the stainless steel, it's not so different. Same from the mild steel. So when we apply the pre-burning with the high quality CW cutting, we can achieve great results here with the sharpness, the roughness. The difference between the top and the bottom also is significantly reduced. So as we saw in the previous cutting samples, cutting of thick material with CW cutting single mode is not an easy job. But what's the reason for this? The thicker the plate is, the more beam output is necessary to increase the melting capacity. But the molten metal cannot pass through the narrow curve the CW cutting creates. So it causes surface roughness, burning, as you saw in the example, and reducing the cutting quality to the point of it is sometimes not acceptable. Of course, the focusing the beam to a wider groove may be effective, but in this technology, this CW cutting single beam, the cutting becomes very unstable due to the deterioration of beam quality. So we can see this, when the beam is far from the plate, the deterioration is worst, and that is the problem it's create. So what is exactly the DBC technology? We saw the single beam. We understand, well, what's the single beam, and what is the DBC is with the double beam control, is while the single beam mode has only the central beam here. We in the DBC has a combination of a central mode, a central beam with a ring beam. And in the DBC, the beam control makes the possibility to control both of the beams individually. And doing that, we can control, adjust each one of the beams separately to find the best condition according to the material type, surface condition, and the surface temperature during the cutting. So the main difference between the single beam and the DBC, the dual beam, is in the single beam, where the laser output is a single beam, is only one beam, while the laser beam divided in central beam and ring beam in the DBC. For single beam, it makes fast cutting into thick thin plates. On the other hand, it requires the increase of output for medium thick plate. But doing that, there's a risk of burning increases depending to the difference in the material surface condition and surface temperature. it's not possible to achieve stable cutting or when cutting medium to thick plates using the single beam, since there is a limitation to high beam output and variable beam shape in the single output. But in case of the DBC, it can change the beam shape in several ways, reducing the heat applied in the plate, preventing the burning from happen, and you can find the best combination of beam output and shape according to each kind of material, surface condition, surface temperature, as I said before. Also, the cutting medium plate and thick plate, it's possible to achieve the stable cutting with this feature. Even for rust material and in thick material. So to maximize the capability of the DBC, 3 main points were newly developed specifically for this technology. One is the new cutting torch, which was developed in-house by KOIKE. In this torch, the design of the optical systems components was being completely renewed to match the DBC oscillator. Additionally, the optical components maintenance now is possible individually, reducing significantly in the maintenance costs. So also a new nozzle was developed specifically for the DBC. And by using this new nozzle, we truly optimized the flow of the assist gas and shielding gas, improving the molten metal discharge. And that one is the solution that gave the less notches in the cutting surface. And in order to achieve the high level of counter accuracy for the CW cutting by this new featured DBC, KOIKE also reviewed the machine structure and completely renewed the driving system for this machine. In this machine, this new model, the customer can choose whether the operation panel, oscillator, and chiller will be installed on board over the machine or standalone or in the somewhere else. So before that, the fiber graph only has the possibility to have the operation panel outside of the machine, standalone type, but now you can choose for onboard type also. The oscillator and chiller is the same. But for the fume collector, the only option is for standalone type. So I guess everyone knows the risks using fiber laser, but recently, if we think recently, never before in the laser cutting systems has the light source being so intense and powerful than in the fiber laser cutting machines now. And comparing to the CO2, the difference is even bigger. So differently from the CO2, the beam of the fiber laser is way more dangerous. Since CO2 laser is able to cut both glass and acrylic, if the beam hit the eye of the operator, it may burn the cornea, causing discomfort, pain, but you can protect your eye using a simple acrylic glass without any special requirement. But for fiber laser, if the light strikes the eye, it passes through your cornea. And if it focuses on the retina, it will cause serious damage there. In this case, special protective glasses are required for using fiber laser. And also, in order to achieve even more safety in the cutting shop, the setting of a laser control area is required for the fiber laser machine. And also entering the control area during the cutting process is not allowed. So what is the control area? Here in this image, we are seeing the machine from the top. So this area here in red is which we call the area where the light leakage is expected to occur. So including the peripheral areas over the machine. So the leakage of the light will be influence all this area here. In this shaded area, is the dead angle where the liquid light does not hit. So this part here is not affected by the light, the fiber laser light. So the operation step is when you choose for the onboard type, the operation step will be installed in this area, here or here. And the control area will be starting from the photoelectric sensor in the front side of the machine, which is like here. This part from here to here, it will be starting the control area. So for operation of the fiber laser, you need to be far from this controlled area, something like 2.5 meters. Also, to increase even more the safety, we have a special design for the cutting table structure. It is specifically dedicated for the fiber laser cutting and was also developed here for these systems. And this system has some measurements to prevent the leakage of the laser beam by using internal partition. Like this is a standard cutting table, which is all open in below side. But for this cutting table dedicated for the fiber laser, we use some partition inside where the fiber beam will be reflected and will stay inside the cutting table or inside the machine. So no leakage will be occur in this system. Also, we improved the skirt gaps and quantity. So we have double skirt in the front and the back side of the machine. And this is also improved the protection from leakage of fiber light. And compared to the CO2 laser, the fiber laser generate a higher amount. What happened? Sorry. Compared to the higher amount of film. So also this film may adhere to the bottom side of the cutting parts more often. In this case, film collection system is indispensable for the environment measurements. What we recommend for the fiber laser is to use the same system we are using for the plasma cutting. So the belt duct system, the same way we use for the plasma, is recommended for the fiber laser. So the only difference between the plasma and the fiber laser system film collection is that the cutting table doesn't need to be filled by water. So the previous type of cutting table you can use with this belt duct system for film collection, but you don't need to fill the cutting table with the water. Okay, this is what I have for today. Thank you very much and appreciate your time.